Yeah, hi. Thanks for the introduction. I'm going to talk about big data and capital management. And this is kind of the agenda. I'm going to give a brief introduction to myself, give a bit of business background as to what the regulatory and business landscape's changing. Then discuss the technology impact of all the capital charge changes that's going on. How does big data come into the picture? Which technologies are relevant to capital management? What are the challenges that people face using these technologies? And then some of my observations, what succeeded with using these technologies for capital management. Feel free to sort of interrupt or ask any questions anytime. So I'll give a bit of history. So, I've been working for an investment bank for a lot of years in many roles. I started in technology, went to the business side on risk management, moved back to technology because I like programming more than sort of analyzing risk. Around 5 years ago, got into Hadoop accidentally. Found it was quite a good match for a lot of the capital calculations we were doing. And then simultaneously, Hadoop matured. You got the second generation of the Hadoop stack. From Hadoop, you into Hive to Spark. And it's been maturing. And I got we put more and more things, more and more calculations on the stack and moved up the stack as well. Then I found out that it was a perfect fit, big data and capital management, things that used to take years and like big teams. You could do it in months, even weeks, with a handful of people who knew the technology stack well. And found out that we were one of the few projects in the bank that were actually using big data. 9 out of 10 projects in the place I was at never went into production. So soon found out that very few people knew what they were doing, and not only in our bank but other banks as well. So talking to vendors, I found out that the success rate of big data projects was quite small. So I figured out there was a niche to sort of start consulting independently, because there are very few people who know big data well, and fewer who know big data and risk well. So that's where I left to be an independent consultant. And since leaving, been consulting for other banks, helping them move their capital calculations on the big data stack. And there's a lot of clients that do these in production now. So that's a brief intro. So with that, I'll just give you a brief background of what's happening, right? So since the Lehman crisis, governments don't want to bail out banks, right? It's not popular bailing out investment bankers and their bonuses. So the amount of capital charges have increased, many magnitudes, right? So there's more and more capital charges. As a result, capital is a large cost of any banking trade. So previously, traders didn't care about risk because the capital charges were a very small proportion of any trading activity or any trading P&L. But now, since the Lehman crisis, capital charges are a large part of any trade. And most of these capital charges are not at a trade level, they are at a bank level. So effectively, what happens is, previously a desk could do their own risk management because they didn't care what the rest of the desk were doing. They could just calculate their risk and P&L using their own trades. But now, the government is interested in the liquidity of a bank or the stability of a bank as a whole. So you can't do, you can't sort of calculate VaR or a capital charge at a desk level. You need all the positions of a bank to calculate capital. And that means, a desk can't do it. You kind of need a large system that consolidates all the positions of a bank and runs the calculations. Also, the regulators are saying you need to run more calculations, more scenarios, use more time steps. So I'll just give you a brief example, right? So 5 years ago, the value at risk was pretty much the only market risk charge that regulators wanted. Today, you have all these and more coming up. So soon, there's a fundamental review of the trading book banking regulations that's going to be implemented. So right now, from one charge that you could do at a position level, there are these charges. These are quite complex charges. They have to be done at a trade level, and they have to be done more frequently. So from one regulatory measure, today there are these, and they're increasing every year. So the summary is, there's more charges. There is significant cost of capital. Traders can't ignore market risk anymore. If you had seen the movie Big Short, you'd see the traders sort of tell the risk managers to go away. Yeah, and that was a common thing 5 years ago. But today, that doesn't happen. The risk impact is the first thing traders want before making a trade. So what you saw was very common in a bank, that risk was pretty much an afterthought. Any market risk feed or a regulatory system feed was done after the fact. Similarly, you would get away with calculating VAR and reporting a lot of these measures once a year or once a month for VAR, once a year for stress testing. That doesn't happen anymore. So you have to run stress test weekly, multiple ones. And in fact, risk management is the only growth business in the bank, or the growth area in the bank. You'll see a lot of front office tech people move to risk IT. So they're not only measures, and they're measured intraday, even pre-trade as well. Because you don't want to make a trade that's profitable and then have a large capital charge that comes out of your P&L. So you'll see, effectively you'll see the same big V's affecting capital management. You have more volumes because there's more measures and they're more granular. The measures are complex, so you need a lot of additional inputs to calculate the measures. I have variety twice, but the other thing is, they are more, the regulators want them frequently calculated, so velocity is more as well. And it's not only sufficient to calculate the measures, but you have to show the regulator all the inputs and audit trail of everything that went into calculating a measure. In fact, most regulators would want architecture diagrams of your stack as well. So the familiar big V's affect capital management as well. Any questions so far? So these are the challenges, facing most risk IT teams in banks, right? And I'll tell you what the current state is. So you don't have to read this, but effectively, in most banks, typically systems that were built for online transaction processing were used for risk management. We use databases, in-memory grids, message queues, and say compute grids as well. All these technologies were never built for sort of analytics. They were built for trade processing or transaction processing. So databases supported logs, transactions, message queues supported commits, transactional commits and things. So these systems, did a lot which were never required for any analytics or risk management, right? But pretty much, there was 5 to 10 years ago, that was the only thing. You had a one-size-fit-all sort of system. You had a database, application server, and some front end on top, and maybe a message queue, MQQ. And that worked well till you had limited measures to calculate. But all these systems were quite complex, right? Because they supported transactions, they supported locks, they supported security at a row level, column level, which none of these were ever required for risk management. And there were many moving parts. There were custom formats, proprietary systems all over the place. A lot of these systems didn't scale, were not resilient. You could just buy a larger box. Were never distributed systems, right? So if you wanted resiliency or failover or scaling out, it was pretty hard to do and retrofit them. So here's what happened, right? around the same time, all the internet giants came across the same problems, right? So Google, Facebook, everyone came in, had 1 million customers to serve. They soon found out that the same things happened. Traditional systems were over-engineered and not well suited to do analytics because they did a lot of things that were never required for analytics. And these were hard to scale, hard to make resilient, hard to distribute as well. So effectively, all these internet giants came across the same problems and came up with a new breed of technologies that we today collectively call as big data. Right? And these things, a lot of people will say the 4 Vs, right? But they don't say how these 4 Vs are tackled by the big data stack. But what the big data stack does is, it can't defeat laws of physics, but what they do is they are specialized in doing one thing and one thing well. So you don't have a one-size-fits-all solution. You have very specialized systems that tackle specific problems and do it well. And that's how sort of you can manage to scale them and process large volumes, do them faster and a variety of formats. So I'll just give you quick examples, right? So HDFS is like the big data file system. It is immutable. It doesn't support updates. It doesn't support, index lookups. And a lot of it is never required for batch analytics versus NFS or a SAN, which does all of it. So the result of being simple and supporting just analytics and being immutable, HDFS is easy to scale out and is a magnitude cheaper and magnitude more scalable than a NFS or the old style distributed file system. Similarly, like Cassandra versus relational databases, Cassandra sort of allows you to relax consistency constraints, and that's how it scales up. It doesn't defeat laws of physics, but it does a few things, it does it well, and if it matches your use case, then it's a magnitude more efficient. The same thing works for Kafka versus message queues, right? Yeah, what Kafka does is it realizes that you don't need to, it pushes the state management to the client. So as a message bus, it's 10 times or a magnitude more scalable than a messaging old style MQ platform, which have to sort of maintain state for each client, and the slowest client can slow it up. Similarly, like Spark versus in-memory data grids, Spark realized that if your in-memory data structure is immutable and doesn't need to support granular updates, you can effectively build a very scalable, analytics-optimized data grid. So these technologies, the way they handle 4 Vs is they're specialized, do a few things, do them well, and if you match the right set of technologies with your use case, you can basically scale out very efficiently and very cheaply as well. So that's really the key to big data, right? You'll see 4 Vs, but no one ever says why these new technologies manage to handle the 4 Vs. And again, all of these are resilient out of the box, are scalable, and can be scaled out using commodity hardware. Not only that, it's easier to run them on the current clouds that are there. And to top, a lot of them are open source, so you have the power of community behind it. I know you would be able to see this, but that was the stack previously. So you had a database, an app server, but right now you can pick and choose a very specialized system based on your use case. Similarly, this was like pre-2000 where you had a database, an app server, and some HTML5 front end. But now for each and every part of the stack, you have multiple choices. And you need to pick, as long as you pick and choose the right one, you can do a lot. You can scale out, a few magnitudes better. Any questions? So a lot of people would say Spark, and there'll be few things in few highly publicized technologies, right? But effectively, a a lot of these technologies sort of from ground up use common frameworks and common libraries and build on top of it, right? So starting from on-the-wire protocols, you have Spark and all HDFS and everything else that you see use these new generation on-the-wire protocols. So it's not just a few things, but there's common components used widely, shared in the open source world that allow all these other components in the big data space to scale out and do things efficiently. So starting from what's sent over the wire or what's saved onto disk, you have very efficient serialization formats. So compared to how Oracle or traditional databases stored things, these are very efficient both on the wire and on the disk. And most of them are open source, right? So Google protocol buffers, Thrift, Avro, not only do they sort of store data very efficiently, they allow for schema evolution. And they support not only simple data types, but even complex ones like arrays, vectors, matrices, maps, and structures natively. You don't have to sort of build them as an afterthought. They support, you can sort of evolve your schema, so you don't need to sort of define your schema upfront. And things like Avro support backward compatibility of schemas and forward compatibility as well. Yeah, if you really look at what you get free by using one of these serialization formats, they are very efficient on the wire. And that's all of that is free with just a bit of configuration. Not only that, all these internet giants, though they compete sort of furiously, at least on the tech stack, it's open standard. So they've contributed a lot back to open source. And you can pick and choose. Fortunately, they've sort of collaborated, and you can pick and choose any of the formats with even Spark and things. You can pick and choose any of the formats behind the scenes. Those were the serialization formats. Even file formats, with like Parquet gives you a columnar database for your own files by just a few lines of code, right? And if you have textual data and you store it in Parquet, you'll get 10 times the compressions you'll typically get by a non-columnar format. So a lot of that Spark, the headline is Spark, but behind the scenes it's reused a lot of these building blocks. So all the big data stack effectively reuses a lot of the underlying components that have been contributed. And thanks to standards, they have been able to do that. Effectively, it means that you can get to market quickly and you have increased productivity. You can focus on your capital calculations rather than focusing on writing a best serialization format and picking the right file formats and things. And then you have things like Spark, which effectively, I don't need to talk about Spark, but effectively it's a very versatile platform that's a very good fit for a lot of the capital calculation and aggregations. Things like Scala, which is a functional language, very well suited for immutable calculations, allows you to write code that's side effect free, which is easy to scale out. And you have new algorithms as well. So in the big data space, you have new algorithms, new data structures. A lot of the promising things are you have, sometimes you don't need exact answers, so you can use probabilistic data structures and approximate algorithms. And again, you don't need to reinvent the wheel. You can pretty much use things off the shelf. Okay, so what Spark allows you to do is, so previously what Spark allows you to do is, it just combines everything, allows you to pick and choose the best storage technology for your problem or for your needs, and stick to a very, a single stack pretty much allows you to do everything you want. The last thing that I've come across, and that's been quite versatile and an invaluable tool in my tool set is interactive notebooks. So effectively, you could sort of build, till recently, you could build a system, but you still had to spend a lot of time building a front end and showing results to your stakeholders, right? So even if you build the analytics, it took a while to sort of demonstrate the results to your stakeholders sometimes. And a lot of times, you were never sure what they asked for is what they wanted until you sort of showed the results to your stakeholders using the right visualizations. It was very hard to sort of get feedback. And interactive notebooks have got that, gives you a very agile platform to show results of your analytics to stakeholders without actually building custom UIs. So this kind of pretty much completes the stack. So you have a very versatile backend, Spark combining the right data sources and using it to implement analytics, and an interactive notebook as a front end where you can sort of combine code, data, visualizations, and get early visibility and feedback from your end users. So that's really a summary of my talk, right? So you have these challenges that banks face thanks to increased regulations. It basically means you have large volumes, more frequent calculations, a variety of data types, and effectively you don't need to reinvent the wheel. You can use the big data stack. It's perfectly fitted for risk calculations where it's analytics workloads only. And if you pick the right set of technologies from the big data stack, you should be able to meet capital management needs very effectively. So in most banks, right, there'll be risk covers. So you really have a choice to stick to the existing stack and keep on sort of adding more database servers, thinking it's low risk, but it may not be low risk as you think. Or you could sort of take the jump and take a new approach. It's not only about cost savings and meeting regulated needs, right? Once you have a stack, then you have scalable compute to sort of do more calculations, do them more frequently, sort of do pre-trade impact analysis. Any questions? I guess I'll come to the challenges, right? So that was the good news. The challenges are, it's hard as well, right? So previously you had one size fit all, but right now, there's a lot of choice, and you have to pick the right technology for your right things. And it's a rapidly changing space as well. Like in 5 years, there's 3 generations of Hadoop. Like when I started, I was pretty much creating my own distribution from downloading Apache Hadoop. They were not even Hadoop vendors. And I sort of rewrote the first system I built on HDFS first using MapReduce, moved to Hive, rewrote it in Spark in 5 years, right? So there's a new project, a new open source project coming every month or even more frequently. It requires a combination of skills, right? You need expertise in a lot of the things use Java. So you need Java expertise, you need data expertise, and you need distributed systems expertise. Big data modeling is completely different than traditional databases, right? It's immutable data stores. Replication of data is good, not bad. So it's like a completely different mindset. On top of it, your functional programming means you need to unlearn Java and start from scratch. And most of the expertise is in sort of startups or .com companies. So there's very few people who know this stack and know risk well. And a lot of times you'll find the right programmers, but they are sort of, they don't have the domain expertise. So those are the challenges. A lot of projects fail because people focus on technology. So you'll have a lot of big data programs, and they sort of lose track of what are you trying to solve. And sometimes, the big data technology is not the answer to everything, right? Sometimes you need a relational database. Sometimes, you don't need, the right thing is to do mix and match and evaluate. You might use some things from the existing stack and some things from the new stack. And then there are vendors that will try to push their products, though they are not well suited. So I think I pretty much covered everything I had to say. There were a few recommendations, which is, keep it simple and be agile, be solutions driven. But I think I'm running out of time. So we have time for questions?
Thank you very much.
Okay, thanks.